Hello, welcome back. We're at question 6. There's the sponsors. They've already got a tick next to them. Let's get into this question. Research was carried out at a maternity hospital to find out the number of days that pregnancies last from conception to birth. The data for this hospital's patients can be modeled by a normal distribution with a mean of 275 days and a standard deviation of 12. A patient at the hospital is chosen at random. Calculate the probability that the number of days that patient's pregnancy lasts is less than 275 days. Now, there's the normal distribution. That's the midpoint. The mean is always in the middle of it. So if we're saying less than, it's going to be the left-hand side of the graph, which is half of it. So our answer for that is 0.5. For the next one, it's not so easy. So we're going to go into our normal distribution, normal, and then we're going to do NCD, and we're going to have a low value, which I'm putting as 290 because that's the value. We want more than 290. Oh, that's a terrible curve. There we go. So there's the mean, and we're looking up at this end here. And then for the high value, I'm going to put like 10,000. Huge number. So the lower, 290, 10,000. The mean, the standard deviation is the first one that comes up there. That's 12, and then 275. That gives me a value of 0.1056. I like to put them to 4 decimal places. It's a bit of a habit from A level. Okay, within 2 standard deviations of the mean, give your answer as a decimal to 4 decimal places. So our value is 275. That's our mean. If I add 2 standard deviations, that's going to give me 299 because 1 standard deviation is 12, so 2 of them is going to be 24. And if we subtract 2 standard deviations, that's going to give us 251. So we need to know the probability of it falling between 251 and 299. What letter am I going to put in the middle of that? D for days? Yeah, that'll do. Days. That's fine. Okay, so into our calculator, the lower value, 251. The upper value is 299. And that gives me 0.9545. Now, I realise in processing that, we might have a figure for 2 standard deviations from the mean. However, that's our accurate one. Wants it to 4 decimal places, so it doesn't want you to just spit out 95% or 0.95. It does want you to go to the detail of finding these figures and then calculating. Okay, part B. At least 70% of pregnancies at the hospital do not exceed n days, where n is an integer. So here's our diagram. There's our mean. And then this bit here, because it says it doesn't exceed n days and n would be here, we've got 70% for that area, making that probability 0.7. So I'm going to need to use the inverse normal. I want my left tail to equal 0.7, and then I keep my data the same. So I've got my mean of 275 and my standard deviation of 12. And that gives me a value of 281.292806. And because we want this to be a whole number and we want the lowest possible value of n, we want 281. Okay, so part C. A research project was carried out at another maternity hospital. At this hospital, the number of days that pregnancies last is modelled by the distribution of the mean being 275, and in this one the standard deviation is 15. 80 patients in the project were expected to have their pregnancies last at least 270 days. So up and down into there. 80 patients, 270, that's below the mean. So that's going to be there. That's these guys here. Okay, so what we need to do from here is we're again going to have to use the standard normal distribution. So we start off by taking the 270 days. We're going to subtract the mean and divide it by the standard deviation. So 270, oh, I'm in the wrong mode. Go back to run matrix. So 270 take away 275 divided by 15 gives us negative 0.3 recurring, negative 0.33. So we need to find the probability of Z being greater than negative 0.3 recurring, because this is where it will be on that graph. Okay, from there then back into stats mode, going into the normal distribution, and we want the inverse normal. I'm going to want the tail to go to the right. My area, no, I'm not going to want to do the inverse at all. I tell a lie. Go back to the distribution, the normal. We need the cumulative. My lower value is going to be negative 0.333333. My upper value, I can put that to 500. And then we want our standard deviation to be 1 and our mean to be 0. Now, by putting that in, I've managed to get myself a value of 0.6293001. Now, what I've put in there, I've actually gone 0.33. So I've rounded that to 2 decimal places. And then I'm going to now use that value because we've got a population, X. It's been multiplied by, let me get this totally right, 0.6293001, and the outcome is 80. So to work out what that population is going to be, it's 80 divided by the 0.6293001. Again, got to go back to run matrix, menu 1. So 80 divided by 0.62930, I'm going to leave it there, which gives me 12712537774, and therefore our answer will be 127 patients taking part in the research project. 12 marks, very doable if you continue. Just practice, practice, practice. Okay, team, I'll see you next time. It's the end of the paper. Good luck for your exams. If this is the last video you're watching, make sure you spread the channel to people in the lower year groups, especially if you do IGCSE. I've got a few bits there for this year's exams, and I'll see you next time. Bye-bye.